Let's start. When I start working on Python, the major concern I have is performance because the Python uses only one core. Even though your machine is multi-core system, it uses only one core. And if my process is, if my program has to use more CPU intensive, then it is very difficult. I have to run multiple such same project multiple times. Like I have to run the container multiple times, right? So, so the alternative to use multiple core is running multiple processes, right? Because process will run on different, each process will run on different core. So, if any of my code is CPU intensive, then what I can do is I can pass that execution into a different process than the process which is running my application. So that will use the multi-core system effectively. So we are going to see how I can create multiple processes and run my code in the other process instead of the main process which is running this my Python project. Okay, hope you got the clarity why we need this multiple processing. Before go into this this code, we have to I will explain few of the concepts because these code you might see this since I'm assuming you are a beginner in Python. So let's go through quickly on some of the coding patterns used in the in this code so that you will have better understanding. Okay, so yeah, first of all, let's see what is iterable because uh, in our code, in process code, we have to pass the argument as a iterable. Okay, so these are the list of iterables. Okay, so like list, tuples, string. So if you pass the list of values um, one by one, because when I say CPU intensive, we are going to give large number of arguments to process, like or large number of repetitive tasks we are going to give. So those tasks, most of the time, it will be a collection. I mean, iterables, which our internally Python process will take and split it and give it to different processes to run together. That's why we have to see this what is iterable. You can see the different iterables which are supported uh, um, uh, it's supported in Python, right? And maybe we the people from other language background they might to understand this what is the difference between arrays and list in Python. Usually list is inbuilt built-in object in Python. How we with this this is a syntax for creating a list, whereas array is something we have to add a module to use it, right? Array module to create array, or the effective approach is using numpy array, creating a numpy array. uh, yeah, yeah. So hope we are good at what is iterable, and yeah, let's proceed further. The next one is perf counter. You Since it is performance related, you might need to measure the time consumption within your code. So usually we can do this by having that time object. For example, what is the current time minus once your code is executed, what is the end time? If you know, then you will know how much time your code is consumed, right? But the time is like it is only millisecond precision. It's only millisecond precision, and if you want more granularity, so the suggestion is using the perf counter. Okay, and the perf counter. Um, one more thing is the timer is always based on a key in the clock timing. Okay, so if your machine is changing your clock time, you ran like 2 o'clock now, and somebody if you are changing your clock time to back to one day before, um, then that is a different time, right? That is a different time. It even that is not an impact your code because you are always calculating a subtraction between start and end. But what they are saying is the perf counter is monotonic, but this is something like a stopwatch. It irrespective of your clock timing, it always stopwatch will run on that moment and it will end on a specific moment, right? So this is better approach. One is precision, another one is kind of stopwatch kind of one. So they are suggesting to use perf counter instead of normal time calculation. And there are other use cases, like if you don't want to count the sleep and you are exactly interested in specific CPU process or current thread usages, then we can still go in deep about process time and thread time than a perf counter. But yeah, this is, let's come back this one in later some another tutorial. But I'm thinking that perf counter will suit for current tutorial is enough to measure the time consumption of your code to measure. Okay, the next one is tuple. You might see some code like the variable comma, the first variable then comma. Yeah, I'm also confused about that one. Usually tuple will start with this is a syntax for tuple. So the important thing is, if it is only one argument, then this is not a tuple actually. So if it is one argument, then we have to use comma so that it will become a tuple. Tuple means it's a collection of elements. Um, yeah. So that is one thing. So this is a way to create a tuple, and then we also see this asterisk with your tuple. We can come back that also in the next one. It's called unpacking. So in simple, use tuple. If it is single element, then use with comma. That means it's a tuple. Okay. The next one is unpacking, because the moment if you have a tuple, right, and your function is expecting multiple arguments, and if you are passing a tuple, that then it will assume that it is a single argument instead of two arguments. It's tuple itself is a single argument, so it will assign it to x variable, but y is missing, right? So for that, we can unpack our tuple with the asterisk symbol. So if you give asterisk then tuple name, then what it will do, it will unpack your individual argument and it will assign to the right argument. Now the moment if you give star dot x, then x will be assigned to 1 and y will be assigned to 2. Okay, so this is called unpacking. This unpacking is possible for two data structure. One is tuple and another one is a map or dictionary in Python. Okay, so for map you have to use two asterisk symbol so that it knows. For example, if your function has a named arguments, right, you can use a map, and the moment if you unpack it, it will assign it to the right key and value. Okay, so that is another unpacking methodology. So yeah, we are good with the initial information which we are going to see in our code. Okay, let's go to our main topic, which is process. Okay, let's see. So we already explained about what is process. So the very first step is you can create a process using multiprocessing module. You can say multiprocessing dot process. So you can say that you can create the process. Okay, then once it's only creating the object, right? It's only created the new object of process, but we have to explicitly say starting of that process, right? The moment if you say start of the process, then that process will be started. Then currently if you see, there are two additional process we created along with our main process. Okay, so maybe if you don't join means you are waiting for that process to complete. So if you don't add these two lines, then your main process will get killed before your child process are executing. So we always have to wait for the child process to complete, then say all process is complete. So whenever it is process, we have to remember two things. One is we have to start a process and we have to wait for that process to complete. Yeah, with the join and start. Okay, so now you got it, what is process and how to create the process, right? You create the process, that's all good. Okay. um, we are going to see the pool, because usually whichever language you choose, uh, you will see a connection pool. For example, DB, if you are talking to DB, you will have a connection pool for DB. If it is threads you are using, thread pool you will have. Then similarly, we have a process pool concept also. This pool concept is because if you want to create some process or thread or connection, it's a costly operation for CPU, for your operating system, right? So you, as much as you can reuse that, it is a better thing. So similar to creating a process, instead of creating a process, we can create a process once and keep it in the pool, and whenever it is required, take it from the pool and run it and return back to the pool, right? That's why we need a pool. We will see that pool in the next one. Okay. Yeah, let's see working code for let's see how we can work, how this code is working, right? Let's say I want to debug this. Okay. Okay. If you are not sure about how to do this remote debugging, I have another video, previous video on this one. So what I did is I created a process. Then I'm going through I'm starting this first process. Okay, assume that I'm starting the first process. You can see this, the main process, it created the sub process. Okay, the first sub process. The sub process is actually, it's passed under, because it's trying to execute our method. Okay, so the target is the function, which function we want to execute in that process. And since the function accepts some arguments, we are passing that argument over here. Okay, since I put a breakpoint, the first process is blocked on this breakpoint. You can see that it is saying that it is passed on it says passed on a breakpoint, right? Okay, let's proceed the next. Let's go to our main process and let's continue. Let's see, is it two processes running? Yeah, it created two sub process, right? Both process, since I put a breakpoint here, both process are waiting here, right? So let's what we can do is we can go to the sub process and continue, so that the first sub process is killed. Okay, now let's go back. Let's go back to verify this join, how this join works. Let's go join. See this, since it's waiting on the join, because one more sub process had to complete. Right? Sorry. So that's join blocking the main process until the sub process is completed. Okay, so let's proceed the second sub process also, and keep some main process. Let's keep some breakpoint over here, so that once the join is once this is completed, we will come to that breakpoint. Okay, we proceed. Okay, I proceeded. Now you see the main process came, because these two processes are done and we came into the last line of our code. Okay, yeah. So hope you understand how to use the process. Let's further proceed. Okay, let's further proceed, because this is not enough. Okay. Okay, next topic is pool, because usually you will use pool instead of process. Okay. Okay, so when you use a pool, this is a syntax. So usually you will start with resource, right? The with resource will ensure whatever connection or pool or whatever we are using, it is closing properly. So it's something like try catch finally block in Java, where we are ensuring that closing the resources properly, with try with resources in Java, similar that in Python with resources. Okay, so the syntax is with multiprocessing, and in this module we want this pool class, and we are creating this one as a pool. The pool has multiple few methods to use our function to execute. For example, this is our target function square, which we want to use it. and this is the argument. Argument is all a list of iterables. Okay, the pool will accept iterables. That iterable only thing we have seen in the previous time, right? Okay, now what this pool will ensure is how many. So currently I create threads based on our CPU count. For example, if your machine has 10 core, then there will be 10 process spawned in this pool, and the numbers which we are giving, the iterables, will be equally split into multiple cores, multiple process, and it will execute all in parallel. And one thing is this pool.map is blocking operation. So it means that all the process completed your code, then as a together as a result you will get it. So it's completely blocking until all. So you don't need to join and wait for every individual process. You have to no need to write, because we don't know, right? Even it's explicit, we have told that it's a number of process, we don't have an object to join. So this pool itself will take care of it. Pool.map, it will wait for all the process to complete to, and then the final results will be returned. Okay, this is the pool usage. Okay, but what will happen if your function accepts more than one argument? Because it is only one tuple, sorry, one iterable which accepts which is only one variable, right? You, if your function accepts more than one argument, you might use star map instead of map, where you have arguments like a iterable only, but it is a tuple of iterable of tuples. Okay, you can see this a tuple, and this is same like map, but instead of single argument, it is for multiple argument of type tuple. Okay, yeah, it's all the concepts remain same. It will wait for all your arguments is passing to the method and getting the final results. Okay, okay, okay. One more problem is, since we created a pool within with the problem is this pool will be ended once these lines are completed, right? We have to, every time we come into this main method, the pool is you keep on creating it. So we are not reusing the pool. Okay, even though we created a pool of process, we are not reusing it. So we can see how we can reuse the pool. Okay, so instead of with it's, we can even create a pool without with resources. Then it's our duty to close the pool. Okay, so because this close will happen on with itself, since we don't use that with resources, so we are explicitly have to close this pool. But the only advantage is we can reuse the pool as much as time we are interested. Okay, um, yeah, okay, let's go further. Okay, even one more thing is, if it is repetitive or list of arguments which we want to work, then this suits well. But there is one more use case that you have a specific compute intensive task that you want to run it as a within another process, but it is a single job. Okay, single job. You don't want to wait your current thread to come wait. You just want to execute it in a separate process, and you don't care. Okay, you can further proceed. Then you can use apply async. Okay, okay. Yeah, let's maybe it is confusing. Let me clarify further. Okay, for example, this method. Okay, in this method, in this function, we want to uh, run this compute square. Okay, we don't want to wait for the results. Okay, we don't want to wait for the results to come, because if you're waiting for the results, then your code is still blocking for the results, but you don't care. For example, some of the work like sending a notification, sending email, sending those things can be offline. Like you don't need to wait for that async operation. You can still further proceed on your core functionality. So that's why the apply sync will be helpful. Okay, so here if you say apply sync, then the target function and its argument you are passing, then you can uh, then this code will still continue. It won't wait for the result to come. This result is not a real result. It's kind of future result. Okay. Then if you want that result of the future filter, then you can call get. The get is again blocked operation because you want the result, right? So this may be blocking one. So usually apply async is for you don't care about the result. Then this code is completely asynchronous. Your code continuously go until this get hit, then it is blocked. Okay. Okay. So you may ask, okay, even though it is asynchronous, I may need to handle it, right? Handle the result of asynchronous, right? So not in the main thread, but somehow I want to handle this the result of the function compute square. Okay, there what we can do is we can add a callback function. Okay, so once instead of get, since get is blocking your main thread, instead of get, it's better to use a callback function so that your main thread is still proceeding further, and the callback will be called separately whenever that the asynchronous task is once completed. Okay, this is one example. Okay, what we have to say, compute the square. Okay, compute the square, this is my argument. Then handle the result in my callback. Okay, for example, this print result is callback function. So once this is returning this result, that result will be given to the callback function, and then you can do whatever you want to do in your callback function. Okay, so that way it's completely asynchronous, no get, no blocking, nothing. Okay, we are super cool, we are going further, right? Okay, then when the callback is fine, all callback is fine, but there may be sometime this the function whatever we want to execute maybe throw some error, and even your callback won't be called. That is one more corner case we want to handle using error handling. Okay, if you see, you along with the callback for successful execution of your compute square, you want to what function you want to call. When the compute square function, if it throws any error, how do we want to handle it? For example, with another function called handle error. So handle error explicitly looking for some error. When the compute square returns throws any error, how we want to handle it. If it is success, what we want to handle. If it is success, that's a callback process result. Okay, and the process result will work on the results computed over here, and handling error is another thing. Okay, yeah. Yeah, this is what I want to cover. Okay, so the main thing is we want to offload our main job to another process so that we can maximize our utilization of core, and even we can write asynchronous programming. Okay, so we have seen two options. One is process, another one is pool. And within pool, we have multiple options of executing repeated multiple repeated task with the map and star map, or it's a specific time intensive job which we want to give with the callback and error handling using this apply async method. Hope this is helpful. Thank you.